Something is wrong with the moon, not on its surface, beneath it, buried under the oldest wound in the solar system, a scar so wide it could swallow a continent. There is a mass of material that has no business being there. It's so dense, so heavy, that it's pulling the ground above it downward by more than half a mile. Scientists have known about it for years and still can't fully explain it. And in 2019, China decided to land directly on top of it. What they found doesn't fit the models. In this video, we're going through exactly what China discovered on the far side of the moon, why it matters, and what it might mean for everything we thought we knew about where the moon came from. Most people have never really thought about this. The moon always shows us the same face. Every time you look up at the night sky, you're seeing the same craters, the same dark plains, the same surface. The other side, the far side, has never been visible from Earth. Not once in 4.5 billion years. This is the result of tidal locking. Earth's gravitational pull gradually slowed the moon's rotation until one orbit takes exactly as long as one rotation. The same face always points toward us. The other face never does. Some people call it the dark side. That name doesn't refer to sunlight. The far side gets just as much as the near side. It refers to mystery. It was hidden, unknown, unreachable. Dark the way a secret is dark. Getting there is genuinely hard, not because of distance, but because of communication. Radio signals travel in straight lines. When a spacecraft sits on the far side, there are 2,000 kilometers of solid rock between it and every antenna on Earth. You can't send commands. You can't receive data. The moon itself is a wall. This is why no mission had ever landed on the far side before 2019. The technology existed for decades. What didn't exist was a solution to the communication problem. China's solution was a relay satellite called Queqiao, Magpie Bridge, named after an old folk tale about two lovers separated by the Milky Way, reunited once a year when magpies form a bridge with their wings. The satellite was placed at the Earth-Moon EL-2 Lagrange point, about 65,000 kilometers beyond the moon, a gravitational balance point where it maintains line of sight with both Earth and the far side simultaneously. This idea had been proposed back in 1966 during Apollo planning. No one ever acted on it. For more than 50 years, the far side stayed unreachable. China finally made it work. Queqiao launched in May 2018. 7 months later, the lander was ready. Chang'e 4's target was the von Karman crater. But to understand why, you first need to understand the structure it sits inside. The South Pole Aitken Basin is the largest confirmed impact crater in the solar system, roughly 2,500 kilometers across, about the distance from New York to Las Vegas, and nearly 8 kilometers deep. It formed about 4 billion years ago when something enormous, possibly a small planet, struck the moon. The impact was so violent that it may have blasted through the crust entirely, excavating material from as deep as 200 kilometers below the surface, potentially exposing the lunar mantle directly at the surface for the first time. That alone would make it one of the most scientifically significant places in the solar system. Then came the gravity data. In 2019, researchers at Baylor University analyzed measurements from NASA's Grail mission, which had mapped the moon's gravitational field using 2 spacecraft flying in formation. Overlaid with surface topography data, the results revealed something unexpected buried deep beneath the basin floor. An enormous concentration of mass. Something dense, something heavy, something that shouldn't be there. The anomaly is pulling the crater floor downward by more than half a mile. Lead researcher Peter James described it this way. Imagine taking a pile of metal 5 times larger than the big island of Hawaii and burying it underground. That's roughly the scale of what they detected. 2 explanations are on the table. First, the iron-nickel core of the original impacting asteroid is still embedded in the moon's mantle. Computer models suggest that under the right conditions, a metallic core could be dispersed through the upper mantle during impact and remain suspended there for billions of years. Second, the mass is a dense accumulation of metal oxides that crystallized as the moon's ancient magma ocean slowly cooled and solidified. Either explanation is remarkable. Neither has been confirmed. And this is exactly where China chose to land. On January 3, 2019, at 2:26 a.m. Greenwich Mean Time, Chang'e 4 touched down on the far side of the moon. The descent started from 15 kilometers up. No atmosphere means no parachutes. Every meter of altitude has to be traded for fuel. At 100 meters, the spacecraft hovered briefly. Cameras and laser sensors scanned the terrain, mapping rocks, identifying hazards, measuring slopes. It found a suitable landing area, completed its descent, and settled quietly onto a surface no spacecraft had ever reached before. Images began flowing back through Queqiao almost immediately. NASA's administrator called it an impressive achievement. Scientists around the world were watching views of a landscape no human had ever seen. Then, the rover deployed. U-22, Jade Rabbit, is small, about 140 kilograms. It carries cameras, ground-penetrating radar, a spectrometer for analyzing rocks and soil, and a sensor for studying solar wind particles. Its mission was simple: drive, observe, analyze, transmit. What it found was not what anyone expected. In early 2022, researchers studying U-2 imagery spotted something that stopped them cold. Two small spheres sitting on the lunar dust. Translucent, between 15 and 25 millimeters in diameter, roughly the size of large glass beads. Against the pale gray regolith, they almost glimmered. Glass has been found on the moon before. The Apollo astronauts brought back samples. Dark, opaque, solid fragments scattered around old impact sites. These spheres were different. Light passed through them. Planetary geologist Zheng Xiao of Sun Yat-sen University said they simply blew their minds. Nothing like them had ever been seen on the moon. Glass forms when rock is superheated rapidly. On the moon, that means impacts. A meteorite hits at high velocity, vaporizes rock in an instant, and as the molten material cools in the vacuum of space, it solidifies into glass. These objects are called microtectites, and they're found on Earth too, scattered around ancient impact sites. The spheres appear to have formed from anorthosite, a light-colored feldspar-rich rock that makes up much of the lunar highlands. A sufficiently energetic impact melted it and allowed it to reform in the vacuum into these unusually transparent spheres. What makes this discovery significant goes beyond its strangeness. If lunar anorthosite can be naturally processed into high-quality transparent glass, it can likely be manufactured intentionally. Windows, lenses, solar concentrators, all potentially buildable on the moon from materials already there. Sending 1 kilogram of material from Earth to the lunar surface costs tens of thousands of dollars. Every kilogram that can be sourced locally makes a permanent moon base more feasible. The glass spheres were just the beginning. In 2021, Chinese researchers announced something that stunned the materials science world. Graphene had been found in lunar soil, naturally occurring, embedded in samples from the Chang'e 5 mission. Graphene is a single layer of carbon atoms arranged in a hexagonal lattice, the thinnest known material in existence, stronger than steel by weight, and a better conductor of electricity than copper. Since it was first isolated in a laboratory in 2004, earning its discoverers the Nobel Prize in Physics, it has been one of the most intensively studied materials in science. Finding it on the moon was not anticipated. The researchers identified graphene flakes ranging from 2 to 7 layers thick embedded in the soil. In some cases, the graphene formed a hollow shell around a core of complex minerals, a structure that suggests it wasn't simply shed from graphite. It was built through chemical synthesis, driven by volcanic activity, solar wind, meteorite impacts, and catalytic reactions with iron-bearing minerals in the soil. Here's why this matters at a deeper level. For decades, the consensus held that the moon was carbon-depleted. Apollo samples showed far less carbon than Earth's crust, and this fit neatly with the giant impact hypothesis. The enormous heat from the collision that formed the moon should have driven off volatile elements, carbon included. The moon, in this picture, should have almost none. The graphene discovery challenges that. So do recent measurements of carbon ions being emitted from the lunar surface. Together, they suggest the moon may carry far more indigenous carbon than the standard model predicts. One lead researcher said the finding may require a fundamental rethinking of the moon's chemical history. Then, in 2024, the far-side samples from Chang'e 6 revealed something even more unexpected. Single-walled carbon nanotubes, sheets of graphene rolled into a cylinder, exceptionally strong, extraordinarily conductive, and until this discovery, thought to only exist as laboratory creations. 2 complex carbon nanomaterials found naturally on the lunar surface. The moon is not a dead world. It is an active chemical environment that has been synthesizing advanced materials for billions of years. The giant impact hypothesis is the leading scientific explanation for the moon's origin. About 4.5 billion years ago, a Mars-sized planet called Gaia collided with the young Earth. The impact was catastrophic. Both bodies were largely vaporized. Most of Thea's iron core merged with Earth's. A vast cloud of debris, mainly mantle material, was thrown into orbit and slowly coalesced into the Moon. The hypothesis explains several things well: the Moon's orbital alignment with Earth's rotation, its low iron content, the angular momentum of the Earth-Moon system. But there's a serious problem. If the Moon formed primarily from Thea's material, it should look chemically different from Earth. Theia would have formed elsewhere in the solar system from different building blocks. Its isotopic fingerprints should diverge from ours. They don't. Oxygen isotope ratios in lunar samples are essentially indistinguishable from Earth's. Same with titanium, same with iron. Earth and the Moon are chemically almost identical at a level of precision that's genuinely hard to explain if they formed from different materials. In November 2025, a team at the Max Planck Institute for Solar System Research published a study in the journal Science addressing this directly. They analyzed iron isotope ratios in 15 Earth rocks and 6 Apollo lunar samples with exceptional precision, then ran mass balance models of different collision scenarios. Their conclusion: the most consistent picture is one where Earth and Theia both formed in the inner solar system. They were neighbors, built from similar materials in the same region of space. This changes the story. The collision wasn't a random encounter between bodies from opposite ends of the solar system. It was a collision between siblings, objects that grew up together and eventually catastrophically merged. Which is why Earth and the Moon ended up so similar. And it raises a new question. What destabilized Theia's orbit in the first place? One leading possibility is that Theia initially formed at a Lagrange point in Earth's orbit, exactly the kind of gravitational balance point where China's Queqiao relay satellite now sits. As Theia grew, gravitational nudges from Jupiter or Venus could have gradually pushed it onto a collision course. We don't have that answer yet, but every new sample from the lunar surface brings us closer. China has not slowed down. Chang'e 6, launched May 2024, completed the first-ever sample return from the far side of the Moon, landing in the Apollo Basin and returning to Earth in June 2024. A second relay satellite, Queqiao 2, was launched in March 2024 to support future missions. Chang'e 7, scheduled for around 2026, will target the lunar South Pole, which may hold water ice in permanently shadowed craters, ice that could be split into rocket propellant, purified for drinking, and used to make a permanent human presence on the Moon economically viable. Chang'e 8, planned for 2028, will test manufacturing technologies using lunar materials directly on the surface. Together, they are designed to lay the foundation for a permanent Chinese research station by 2029. China is not alone. NASA's Artemis program is aimed at returning humans to the Moon, also focused on the South Pole. The European Space Agency, India, Japan, and other nations all have missions in development. The Moon is becoming the most contested destination in space, not for flags, but for infrastructure, resources, and answers. The Moon has been in the sky for as long as there have been eyes to look up at it. It stabilizes Earth's axial tilt, giving us seasons. It pulls our tides. Its presence may have been a necessary condition for the emergence of complex life on this planet. We have shared the sky with it for all of human history without truly knowing what it is. We went there. 12 people walked on its surface between 1969 and 1972, left footprints that will remain undisturbed for millions of years. And then we left. For more than 50 years, no human returned. We are going back now. Robotic missions have mapped the Moon, drilled into it, analyzed its soil, and brought its rocks home. Human missions are being prepared. Permanent bases are being planned. And the far side, the unreachable hemisphere, off limits for all of human history, is now an active research destination. We have landed there. We have driven across it. We have collected samples and brought them home. What China found there is real. The glass spheres are real. The graphene is real. The carbon nanotubes are real. The mystery beneath the surface is real. These are peer-reviewed, internationally verified scientific results. They tell us the Moon is stranger, richer, and more complex than we assumed, that it has a chemical history still being written, that it carries materials worth studying and worth using, that the giant impact that formed it may have unfolded differently than our models predicted. The anomaly beneath the South Pole Aitken Basin will eventually be explained. The far side samples will be fully characterized. The question of where Theia came from will be narrowed down. New discoveries will arrive with every mission. And somewhere in that process of answering questions, new questions will appear. That's how it always works. Every answer is also a door. The far side is no longer dark.